So let's look at a simple application that demonstrates socket programming. So I'm here at the Learn page, whatever, for our course, lecture handouts, and let's go down to socket programming, and okay, so this is the server code handout, and I think what I'll do is actually first in green I will underline all of the socket API function calls that I described on the previous page. So let's just say that this is page, I believe this would be page 9 of the network's notes. So we've got the call to socket, and I'll come back and explain all this after. There is bind, there is listen, there is accept, and there is read, which is analogous to receive. It's very similar. And write, which is very similar to the send function call. Okay, so now I should tell you what's going on. So first thing we do is we create a socket, and we have to tell it the address family, and it's INET. There's a bunch of address families. X25 is an old network that it could handle. Unix is another one that can be used for just basically talking to another process on the same computer. There's a bunch of them. And anyway, then you have to tell it what kind of connection you want. So a streaming connection basically implies that you're going to be using TCP. The other option is socket dgram, which would be for UDP, and then the 0 here, it doesn't really matter. It's the protocol family, and it's usually always the same as the address family, so it's going to be internet. Okay, so check to see if we got an error. We get back an integer, which is the socket file descriptor, and now we want to bind to the socket. Before we do that, we create one of these structs and we initialize it. We tell it what kind of address family, we tell it the port number, and this H2NS is the host to network, and that is the byte order. So networks are little endian, so it makes sure that the data is recorded in little endian, and then it is a short int, so I believe that would be 16 bits. Okay, and so it's got a port number, but we haven't given it the actual IP address, and that's what the next line does. So we call this INET P2N right here, and P2N I'm pretty sure stands for pretty to numeric or something like that. So the pretty address is this one here. It's just a string. It's easy for a programmer to type and read, and so that's the loopback address. So it's going to connect back on the same computer, and it converts it into its numerical representation. So then we bind, and so we tell the operating system that we want to use this particular port. And next we tell the OS that we're going to listen right here, and we can tell it how many, so we give it the socket file descriptor, we can tell it how many outstanding connections we want to have. If we just want to have one, then we're not expecting other connections to be coming in. Like it's how big your backlog can be. I guess I could have made that 0 too. And then when we accept a connection, we're going to get back the client information. So that goes into the client address structure right here. And you notice we're getting back a new file descriptor. So every time you call accept, you're giving it the main socket file descriptor. It creates a new socket. And a socket is basically identified by 4 pieces of information. The source IP, the source port, the destination IP, and the destination port, or who you're connected to, I should say, rather than source and destination. The other end of the connection. So we are accepting a new connection, and so we'll use this new sockfd to communicate with the client. And we could, in the meantime, if we were multi-threaded, start accepting other connections, but we're not going to do that because it's a simple example. So now we're connected to the client and we can talk. So we've got this, we're going to first receive or read a message over the socket, and then we will print it out. So that's when we printed out the request, and the text of the request happened to be a request. And then we're going to send a response. So we're going to write to the socket, and what we're going to write is this message right here, response. Then we can close the connection with the client, and then it's not a bad idea to just close your socket down. And that's the end of the server code. And this could be page 9 of the network notes. Could be, it is. And so let's just go through and underline, identify the calls. So there's socket, and then connect, that's a new one, and then write, and then read. And so what's different here is this get host by name. So we used localhost, which is an alias for 127.0.0.1. I guess one thing to mention while I remember it is there's another address family which is INET6. So by choosing AF INET, I'm actually choosing IP version 4. If I do INET6, then I'm choosing to use IPv6, and the local host or the loopback address for IPv6 shortens down to this. So it's a whole bunch of zeros, 127 zeros with a 1 at the end. So that would be how it would be done if we were using that. You might not want to write that down, you might not remember afterwards, I don't know. So anyway, so it looks that up, it does a DNS lookup, and it gets the address into here. And when you do a DNS lookup, you actually get you can get more than one IP address back, because sometimes a host name will actually resolve to a bunch of servers. So we just picked the first one off that list, so the first one in the address list, and we're going to copy that into our server address, and we're going to use that when we connect here. And then once we're connected, we're going to write our request, send that over to the server, and then we'll wait for the response here, and then we'll print it out, and then we should close our socket, and that is the client. So next up, I'm going to show you this code running using Wireshark to capture the network packets that are going by.